Friends, welcome back in yet another episode of P block element. In last class, we have discussed general introduction of P block element. Now in today's class, we will discuss about group 15 elements. Group 15 elements belongs to nitrogen family because the first element of this group is nitrogen and the rest of the element of this group are phosphorus, arsenic, antimony and bismuth, and they have the general valence shell electronic configuration of Ns2Np3. N represent principal quantum number. By knowing the value of N, we can easily write the valence shell electronic configuration of any of the element belonging to this group. In case of nitrogen, the principal quantum number is 2, so the general valence shell configuration will be 2s2 2p3. In case of phosphorus, the principal quantum number is 3, so the general valence shell configuration will be 3s2 3p3 and so on. Now the next topic, periodic trends of group 15 elements. Periodic trends in terms of properties of group 15 element. The first property is atomic and ionic radii. Point number 1, covalent and ionic radii increases down the group. Why there is increment in the value of covalent and ionic radii? The answer is very simple. What is that answer? You have gone through the concept of Selling effect and effective nuclear charge. On moving down the group, as we move down the group, the atomic number goes on increasing, and with the increase in atomic number, the core electrons also goes on increasing, but the valence electron remains same. And core electrons shielded the valence electron more effectively down the group, as a result of which shielding effect get maximized, on due to which the effective nuclear charge decreases and the atomic and ionic radii goes on increasing down the group. This principle is applicable for all the group. Now the second point, there is an appreciable increase in the covalent radii from nitrogen to phosphorus. The third point, there is a small increase from arsenic to bismuth due to presence of completely filled d or f orbital in heavy elements. And due to the complete filled d and f orbital, the shielding effect get maximized, and consequently the effective nuclear charge become very minimum. So there is a sudden increase in the value of atomic and ionic radii down the group. The next point, ionization energy. Let us understand what is the meaning of ionization energy. You have gone through this topic in your class 11 syllabus. The minimum amount of energy is needed to remove an electron from the outermost orbit of an isolated gaseous atom, that is called ionization energy. In case of group 15, it goes on decreasing down the group due to increase in the atomic size. You must remember this point, that as the atomic size increases, the value of ionization energy decreases. Group 15 elements having higher ionization energy than group 14 elements due to the smaller size of group 15 element. There is another factor that can be explained this point. The general valence shell configuration of all the group 15 elements Ns2Np3, which means the p orbital is half filled, half-filled orbital causing the maximum stability. So therefore, to remove the electron from the half-filled p orbital in case of group 15 become more difficult as compared to that of group 14 element, which has ns2 np2 valence shell configuration, and as a result of which group 15 elements showing higher ionization energy than group 14 element. Now the third point, the group 15 elements having higher ionization energy than group 16 element. Again the reason same. In case of group 15 element, the valence shell configuration is belongs to ns2 np3. It is half filled, so causing the maximum stability and the removal of electron from the half filled orbital become more difficult. Whereas in group 16, the general valence shell configuration ns2 np4, which means it is unstable, beg your pardon, which means it is very unstable, and that's why the group 16 element having tendency to lose the electron, showing the lower ionization energy value as compared to that of group 15. These are the exceptional case that we have to remember. Now another property, allotropy. All the elements of group 15 except nitrogen shows the allotropic behavior. Catenation. What is the meaning of catenation? As you have read in your earlier classes, class 11, that carbon has tendency to show the catenation property, and due to the catenation property of carbon, it forms large numbers of compounds. Similarly, the group 15 element showing catenation property but not as much as compared to that of carbon, because the size is the matter, and nitrogen shows catenation to some extent due to the presence of triple bond in nitrogen molecule. Due to the formation of triple bond, nitrogen has tendency to interact with the another nitrogen atom and it form catenation. Simply catenation means linking with identical atom. And as the size increases, the catenation property decreases. In compared to as compared to nitrogen, the size of the phosphorus is very larger, so it has no tendency to show the catenation property to maximum extent. And as I have mentioned earlier, that number 2 is showing the tendency to show catenation decreases down the group. If somebody will ask you that why it's happened, the answer is very simple, that as the size increases, the tendency to linking with identical atom decreases, and consequently the catenation property decreases. Among all the p block elements, carbon is the only element which shows the maximum catenation property. And due to showing the maximum catenation property, carbon can form large number of compounds, which results the generation a new branch of chemistry, and that is organic chemistry. Now move on to the another point of group 15 element, oxidation state. Oxidation state is very important point for group 15 element as well as for all the p block elements. The common oxidation state are +3, +5 and -3. It is important to note that being a first element of the group, nitrogen showing negative oxidation state of -3, and that is equal to its valency. As all of us we know that in case of nitrogen there are 5 electrons in the valence shell. So it is less than octet and has tendency to gain 3 electron, showing -3 oxidation state. So it is very important to remember all the p block elements but belonging to a particular group. The first element always shows the negative oxidation state. First element always shows negative oxidation state. This is only because of their exceptionally smaller size and high nuclear charge. And the remaining two oxidation state, +3 and +5 oxidation state, which are very common in group 15 element. On moving down the group, the stability of +5 oxidation state get minimized, whereas +3 oxidation state get maximized. We have gone through this topic. This is only because of the inert pair effect. Because on descending down the group, tendency of s orbital to lose the electron, its 2 electron, become less, and as a result of which the lowest oxidation state become more stable, and which is only because of the removal of 3 electrons from p orbital. As we know that the general valence shell configuration for group 15 element NH2 NP3. Now move on to the next point that I have already explained. The stability of +5 oxidation state decreases, whereas the stability of +3 oxidation state increases due to inert pair effect. Next point, nitrogen shows oxidation state from -3 to +5. There are various compounds of nitrogen are known in which its oxidation state ranging from -3 to +5. Nitrogen and phosphorus with oxidation state from +1 to +4 undergoes oxidation as well as reduction in acidic medium. This process is called disproportionation. What is the meaning of disproportionation? I think I need to make it more clear. When the same element, listen it carefully, when the same element showing both oxidation and reduction in a particular reaction, those type of reactions are known as disproportionation reaction. And this can be illustrated by the given example, and that is the nitrous acid converted into nitric acid, water and NO. In nitrous acid, when you find out the oxidation state that you have already studied in your class 11, you will find that the nitrogen showing both oxidation and reduction in their compound, that is HNO3, HNO2 and NO. So such type of reactions are known as disproportionation reaction. In my next class or next lecture, I am going to explain in detail about disproportionation reaction and some of the properties which has still remain, that will be discussed in next lecture. I hope that all of you have enjoyed this particular class of P block element of your CBSE syllabus, and I am trying to explain each and every single topic so that you can understand it properly. And I am continuing this particular lecture purely in English because there are so many students across the country in different parts, they are unable to understand in Hindi medium. So I have decided that I am delivering particularly this series in 100% English form. And those students who are unable to understand English properly, they have to wait for some time because I am going to start another series for the CBSE student of North India so that they can be also benefited. If you like my class, then do consider subscribing and make your valuable comments in my comment box so that I can respond your queries and make you happy by giving your answer. Thank you.